Hello Math 10 students. Today we're going to cover factoring the difference of squares. Of course we're going to start easy, but then it's going to get harder. So to factor the difference of squares, always remember the difference of squares, you always have two terms. It's a binomial, so you have two terms. So like the first one, x squared is one term and then 16 is the second term. And both of these terms have to be perfect squares. Perfect squares means that we could take the square root of that number or that variable. So here the square root of x squared is x and the square root of 16 is 4. So all we need to do, open two set of brackets always when you factor in difference of squares, and then take the square root of the first term and put it at the beginning of each brackets, and then throw a minus sign in one bracket and a plus sign in the other brackets, and then take the square root of the second term and throw it at the end of each brackets, which is the square root of 16 is 4. Let's get started. So here is the first question. Again, we open two set of brackets, take the square root of x squared. That's going to be xx. Throw a minus and a plus, or a plus and a minus, and take the square root of 16, and that's a 4. And that's it. Also, I want to bring back to your attention that factoring is the opposite of foiling. So let's say if we take x plus 4 and FOIL it into x minus 4, you're going to get x squared minus 4x plus 4x. Sorry, that's minus 16. And if you collect like terms, you're going to, negative 4x and the plus 4x there are going to cancel. And therefore you get x squared minus 16. So foiling is the opposite of factoring. However, if you have x squared plus 16 and we say factor it, because the sign in the middle is not a plus, it's not a negative, then you cannot do it. And see, if you're thinking of you're just going to go x plus 4, and if you end up foiling that, guess what you're going to get? You're going to get x squared plus 8x plus 16. And that's not the original equation. So that's why we cannot do the sum of squares. Now we'll go to the second question. And we know we're going to do the same thing. Open two set of brackets. Minus plus in the middle. Square root of 81x squared is just 9x. Throw that in both brackets at the beginning. And then the square root of 25 is 5. And you repeat the same thing in all these questions. Square root of 4a squared is 2a. The square root of 9b squared is 3b. And you just go 2a plus minus 3b. How about 81k to the 4 minus 1? Again, you follow the same thing, but you have to look at the end what's going to happen though. So 9k squared, that's the square root of 81k to the 4. So we end up with 9k squared plus 1, 9k squared minus 1. But the only thing is the 9k squared minus 1, you could still do that again. But not the 9k squared plus 1. As I explained earlier, you cannot do the sum of squares, but you could do the difference of squares. So you just copy paste the 9k squared plus 1 there, and then the 9k squared minus 1, you're going to factor that into two set of brackets, and it's going to be 3k minus 1 and 3k plus 1. So again, square root of 9k squared is 3k, and the square root of 1 is 1. And now again, here's another one that freaks everybody out because it's fractions. But it's the same thing. You just square root the first term, and that's going to give you x over 6. The square root of x squared is x, and the square root of 36 is 6. So you write that on both terms, and then you square root the 49 over 121, that's 7 over 11. 7 over 11. Of course, there's a minus and a plus sign in the middle. And this one here, lots of students get confused on this one. Believe it or not, you have two terms. The first term is x minus 2 squared, and the second term is 9. So the square root of x minus 2 squared is just going to be x minus 2. And I put 2 square brackets there because just this is long, and the square root of, as I said, x minus 2 is squared is x minus 2. I write that in both brackets, and then minus and a plus, or a plus and a minus. Square root of 9 is 3, and you put that there and there. Having finished, you have to simplify. So you're going to get x plus 1 because negative 2 plus 3 is 1, and then x minus 5 in the second brackets. And that's that, and then we're just going to make space for the other 3 questions. And so we have 8x squared minus 72. These 2 terms here are not perfect squares because 8 isn't and 72 isn't. So we cannot just open 2 set of brackets and then factor this. It doesn't work. But we have to look for the greatest common factor, and that's the first thing we learn in factoring. And the greatest common factor between the 8 and the 72 here, 8 is, and therefore you're going to get x squared inside the brackets minus 9. Now you carry on the 8 and then factor x squared minus 9, and that's going to give you x minus 3 and x plus 3. And now we're going to do question number 8, and that is 7x to the power of 4 minus 7y to the power of 4. Right away I see a 7 here is the greatest common factor because it's not a perfect square binomial. And you cannot do the different squares right away until you factor out the 7. And when you factor out the 7, you're going to get x to the 4 minus y to the 4. Now, these 2 are perfect squares, and when we factor them, we're going to get x squared plus minus y squared, because square root of x to the 4 is x squared, and square root of y to the 4 is y squared. Now, x squared minus y squared is still the difference of squares. So carry on the 7 and the x squared plus y squared, but the x squared minus y squared is going to factor into x minus y and x plus y. And now the last one here, 27m cubed minus 12m, I'm just going to move it to a different page. So there, number 9, I added number 10 to that. You have 27m cubed minus 12m. As you see, none of these terms are perfect squares. But what do you notice here? We should notice that there's a greatest common factor, and the greatest common factor here is going to be 3m. You open brackets, now 27m cubed divided by 3m is going to give you 9m squared, and minus 12m divided by 3m is going to give you 4. Now 9m squared minus 4 is a binomial with 2 perfect squares, so we could use the factoring of the difference of 2 squares for that. So we carry the 3m and we open 2 set of brackets. We're going to have 3m in both brackets and minus plus, and then square root of 4 is 2, and that's the answer for that one. Now how about this question? It looks a little bit more complicated, but it's the same thing. You open 2 set of brackets, you take the square root of the first term, and the square root of x minus 2 squared will just be x minus 2. And of course, you gotta write that in both brackets right at the start of the both brackets. And now you put a minus and a plus, and then the square root of x plus 3 squared is just gonna be x plus 3. And so you put the x plus 3 in the second bracket without brackets around them, but that's when it's minusing, you have to put the x plus 3 inside brackets. And the reason, because the negative is a sign changer. Now this becomes x minus 2 minus x minus 3. And here you could just collect like terms right away because it's all good there. So 2x, the x plus x, and negative 2 plus 3 is positive 1. And the second bracket's x minus x is going to be 0, and have negative 2 minus 3 is negative 5, brackets to x plus 1. And that's the answer for that one. And here, as I promised, 2 questions for you to try. Challenging questions. Here is the first one, and this is the second one. I hope you enjoyed this video. You learned something from it. Good luck on your questions. Post your answer. when you're done.